Alright people, so in this video we'll be discussing your solid state previous year question which was asked in your IIT-JAM chemistry examination 2020. So let's begin with the video. So the question is, a first order reflection of X-ray from 2 to 0 plane of a copper crystal is observed at a glancing angle of 22 degrees. The wavelength of the X-ray used is in picometers. We have to find out the wavelength in picometers. So additional given information here is copper forms FCC crystal with unit cell edge length of your 361 picometers. So the gist of the question is, a copper crystal is forming your FCC kind of a crystal, right, with the edge length of your 361 picometers. And if you perform X-ray method using your Miller indices of 2 to 0 plane, first order reflection method, right, so the glancing angle would be 22 degrees, right? So we have to find out the wavelength of the X-ray used in this particular experiments in picometers, right? So these all are the values given, that is n equals to 1, your first order reflection. You can see over here that's the first order reflection, so n is 1. HKL, that is your Miller indices value, is 2 to 0. Theta, that is your glancing angle, is 22 degrees. Z is 4 because the copper is forming your FCC crystals, and we know that for FCC crystals Z is 4, right? And the edge length is your 361 picometers, so A is 361 picometers, right? So we have to find out the value of your wavelength of the X-ray used using this all given information, right? Now using by seeing all this information, right, one thing would stick to your mind, right? One thing would come to your mind, that we can use the Bragg's equation, right? We have to find out the value of lambda. So by using the Bragg's equation, we can find out the value of your wavelength, right? So basically the Bragg's equation is this: n lambda equals to 2d sine theta, right? So n is given over this n is given over here, right? That is n is 1. It's a first order reflection, so n is 1, right? And 2 is a constant, right? And theta is 22 degrees. If we somehow find out the value of your d, that is your interplanar distance, right, using any formula, and substitute over this value, right, so we can easily find out the value of your wavelength, right? So we have to find out the value of your d, that is your interplanar distance, right? And for your cubic crystals, the interplanar distance is represented by this particular formula, right? For cubic systems, I'm repeating, for cubic systems where your edge lengths in x direction, in y direction, and in your z direction are equal, that is your a, b, c are equal. So in that case we can use this particular formula, that is dhkl equals to a divided by under root h square plus k square plus l square, right? And all of these values are given in the question, right? A is already given and hk value is already given to us, right? So if we substitute the values of a and L value, that is your Miller indices, in this particular kind of expression, right, so we would end up in getting the value of d, that is your d for 2 to 0. Here 2 to 0 is representing your Miller indices, right? So the interplanar distance for 2 to 0 plane is 127.63 picometers. So this is particularly value of your d, that is your interplanar distance, is 127.63 picometers, right? So if we substitute the value of d over here, that is your 127.63 picometers, right, so we would end up in getting the value of a lambda, right? So if we substitute the value of n, that is 1, it's a first order reflection, 2 is a constant, and the d we just found out the value of d, that is 127.63 picometers over here. And theta is already given to us in the question, right? As you can see, theta, that is your glancing angle. Theta is also known as your glancing angle. So glancing angle is already mentioned in the particular question, that is a 22 degrees, right? So if we substitute the values of theta here, 22 degrees, so we would get the value of your lambda, which is asked in the question, your wavelength, right, of your X-ray. So if we solve this particular mathematical equation, so we would get the value of lambda is 95.62 picometers. So basically the lambda of, that is the wavelength of your X-ray, uses 95.62 picometers. So now this is how you can solve this particular kind of a question. It is pretty much simple question, just you have to be clear with your concepts and you need to solve this question step by step. All right.